At 300 kilometers per hour, one mistake can erase control on massive motorcycle racing circuits. What looks like asphalt is a system of science, heat, and precision built for extreme speed. From the air, these massive motorcycle racing circuits seem calm, but every millimeter below decides survival. This is not just a racetrack. This is engineering in motion. Now, let's begin the journey. At 300 kilometers per hour, speed stops being thrilling and starts becoming physics, where grip is the only thing holding riders to reality. Here, the tire barely kisses the asphalt, yet that tiny contact patch carries enormous force, pressure, and responsibility. From above, the circuit looks peaceful and controlled, hiding the chaos that unfolds on the surface below. What you race on is not just asphalt, but a layered system built to absorb, distribute, and control extreme energy. Flatness is tested long before racing begins, because even millimeters can change stability at high speed. Every stone in this surface is engineered to interlock, creating grip that resists heat, stress, and time. Before any race exists, machines move together in rhythm, building precision through coordination and discipline. This track's shape follows physics, not creativity, designed to guide speed safely through every curve. Once a military runway, this ground has evolved, transformed from launching aircraft to launching velocity. Riders lean until gravity almost wins, trusting the surface beneath them with absolute faith. As temperatures rise, materials soften, and grip becomes a delicate balance between control and loss. Even under brutal rain, engineered drainage keeps the surface alive, proving that grip is never accidental. A wider track allows multiple racing lines, but each line adds stress, heat, and pressure to the asphalt beneath. At full speed, overtakes look fearless, yet every move depends on invisible grip holding the tires in place. Under extreme heat, asphalt can fail silently, as bitumen rises and begins to bleed across the surface. That glossy shine is dangerous, turning engineered grip into something unpredictable within seconds. When traction disappears, physics takes control, and even the best riders have no margin left. Gravel traps exist for this moment, absorbing energy and protecting lives when the surface gives up. At this level, damage cannot wait, and repairs begin immediately to restore trust in the track. From above, the circuit is stripped bare again, resetting the surface so that engineering can start fresh. Every great circuit begins as a simple line, where experience guides the hand before machines ever touch the ground. Digital models bring that line to life, revealing forces and stresses invisible to the human eye. Engineers focus on corners first, because water, speed, and danger always meet there. In simulation, mistakes appear safely, long before they can threaten real riders. Every number on these screens represents balance between grip, safety, and performance. Rain is never an afterthought. Its path is designed long before the first storm arrives. Virtual laps allow engineers to feel the track before it exists, refining ideas without risk. Telemetry confirms whether theory survives reality, turning data into confidence. Collaboration transforms individual knowledge into a single, precise solution. When planning fades into soil, engineering leaves the screen and becomes real. Before precision can exist, nature must step aside, making room for engineered control and purpose. From above, the land looks empty and raw, waiting for structure, direction, and intent. Topsoil is pushed away first, removing organic layers that cannot support speed or weight. Wet earth is stripped down carefully, exposing what lies beneath years of growth. In hours, green fields disappear, replaced by a blank canvas of possibility. Old concrete is broken apart, erasing past function to prepare for something faster. Rubble is collected methodically, because chaos has no place in precision work. Loaded trucks leave the site, carrying history away, piece by piece. A clear corridor appears. Slopes are shaped gently, defining how water and momentum will behave. The ground is compacted firmly, tightening the earth beneath future forces. From the air, the track's curves emerge, carved directly into the land itself. Strong foundations begin with the right soil, placed carefully to support everything above it. Each layer is spread evenly, because uneven ground creates invisible weaknesses later. The texture of this soil matters, uniform and clean. Built to carry extreme loads, heavy rollers vibrate relentlessly, forcing air out and strength in. Even as daylight fades, the work continues, because stability cannot be rushed. Corners are shaped with intention, banking designed to balance speed and force. Multiple machines work together, maintaining consistency across the entire track. Compression locks particles together, turning loose earth into a solid base. Under artificial light, imperfections reveal themselves clearly. Geotextile fabric separates layers, protecting the structure from contamination. Drainage systems are buried quietly, preparing for storms yet to come. The finished subgrade now flows smoothly, ready to accept the next layer. Laser tools confirm precision, ensuring the foundation meets exact specifications. Steel forms the skeleton of the track, giving strength to everything that will follow above. Each reinforcement grid is placed carefully, because alignment defines durability. Sunlight passing through steel reminds us that even hidden strength has structure and order. Every wire tie matters, transferring forces cleanly across the surface. At night, the grid waits silently, ready to receive its final weight. The concrete pump extends outward, bringing controlled power to a massive task. Wet concrete flows heavily, carrying the future of speed in every movement. Workers guide the mix precisely, because uneven concrete cannot be corrected later. Human hands and machines work together, turning control into accuracy. Laser-guided screeds erase imperfections, leaving nothing to chance. Vibrators release trapped air, increasing strength where it cannot be seen. Long finishing tools smooth the surface, transforming raw material into precision. The concrete stretches forward endlessly. Quiet now, but critical forever. Power trowels polish the surface, sealing strength into form. As the sun sets, the concrete cures, locking the foundation of speed in place. Everything begins with raw materials, stone and binder, waiting to be transformed into performance. Racing asphalt is a precise formula, where aggregates, bitumen, and polymers bond for grip. Unlike ordinary roads, racing surfaces sacrifice comfort to gain control at speed. Each sample is weighed carefully, because balance defines consistency across the track. Compression testing reveals how the asphalt will behave under extreme force. The mixing plant stands like a factory of precision, feeding science into motion. Aggregates rise through conveyors, starting their journey toward controlled speed. Inside the mixer, materials churn violently, forming strength through heat and motion. Molten asphalt drops into trucks, carrying energy locked at high temperature. Steam rising from the load signals heat that must be preserved. The asphalt is sealed and protected because temperature loss means performance loss. Trucks roll toward the circuit, delivering science to the surface where speed lives. Every racing surface is built in layers, each one carrying a specific responsibility under speed. The first load of hot asphalt arrives, timing critical as heat begins to escape immediately. The paver moves forward slowly, laying a clean black path where raw ground once existed. Inside the machine, augers spread the mix evenly, preventing weak points from forming. The screed defines thickness precisely, shaping strength millimeter by millimeter. Steam mises aggressively, reminding crews that temperature controls everything. From above, machines move in sequence, a paving train built on coordination and trust. Steel rollers compress the base layer, tightening structure and stability beneath. Water sprays continuously, keeping steel clean while asphalt stays workable. At the edges, skilled hands finish what machines cannot reach. The second layer follows smoothly, reinforcing the system beneath the surface. Multiple pavers work together, ensuring uniformity across the full track width. While still hot, seams disappear, turning separate lanes into one continuous surface. The final surface layer may be thin, but it decides everything about grip and control. This mix is engineered to bite hard, holding tires steady at extreme lean angles. Thermal imaging reveals heat spreading evenly, confirming perfect paving conditions. Temperature checks are constant, because even a few degrees can change performance. Dark clouds gather quickly, threatening to undo hours of precise work. Operators stay focused as rain begins, protecting the process without slowing down. Raindrops vanish instantly on contact, turning heat into thick white steam. Inside the cabin, visibility drops, but control and timing remain exact. The crew accelerates their rhythm, racing cooling temperatures and incoming rain. Rubber tire rollers knead the surface gently, locking grip into the final layer. From the air, the finished curve stands out sharply against vibrant green land. At the micro level, the surface is tight, uniform, and free of weakness. As the sun breaks through clouds, the track reflects success against the odds. The new surface rests quietly, curing with time as strength develops beneath the silence. A small testing robot moves forward steadily, scanning smoothness with mechanical precision. Live data appears instantly, confirming consistency across the racing line. Grip is measured scientifically here, removing guesswork from performance. A test car pushes the limits carefully, validating trust in the surface below. Red and white curbs are installed, defining boundaries where control meets aggression. Safety systems rise alongside the track, completing protection without distraction. Grid markings are painted cleanly, signaling order before competition begins. From above, the entire facility reveals itself, unified and ready for speed. A tire crosses the line, compressing perfectly against engineered grip. Racing returns at full intensity, speed finally meeting preparation. As the sun sets, the circuit stands complete, a balance of science, strength, and motion.